So I would just like to finish off with the section on conjugate additions by just mentioning two really important things that we need to look at. So conjugate additions, we've covered now the basic unsaturated carbonyl reactions. We've looked at a whole host of these. We looked at the reasons for 1,4 addition versus 1,2 addition. But the one thing I just want to point out is that this unsaturated carbonyl is not the only type of structure that undergoes a conjugate addition. We don't need a carbonyl. Other structures that are important are the nitrile, so something that looks like that, and also a nitro of both functional groups, which are really actually very good at undergoing conjugate addition. In fact, in some respects, they're a lot easier to work with and to understand, is that these will always just undergo conjugate addition because both of the centers that are equivalent to the carbonyl, so this carbon here or the nitro, both of those are not electrophilic. So any nucleophile is only going to undergo a conjugate addition, and those are very easy to work with. The second thing that I just want to point out is the concept of nucleophilic epoxidation on unsaturated carbonyl compounds. And you should be familiar with this as a reagent, CPBA, metachloroperbenzoic acid, which is an epoxidation reagent which is often used in organic chemistry. And it's an electrophilic epoxidation catalyst. In other words, the alkene acts as the nucleophile in this, and you should go and make sure that you understand the mechanism that this happens. However, unsaturated alkenes, unsaturated systems like this, have an option to epoxidize using a nucleophilic sense, and the one option is to use hydrogen peroxide, H2O2, with some base, some hydroxide. And what that'll do is it'll give us the epoxide product that will look like this. Now, how does this happen? There's some important chemistry that's surrounding this and where it happens. The first thing is that peroxide, so we draw that out over here. Peroxide, it kind of looks like water. We've got hydrogen and oxygens and that sort of thing. It's actually a lot easier to remove this H than normal water. That's why the base is over there. So we can use this base. We'll very readily deprotonate this proton, and we get the negative charge on the oxygen like that. So then we get this peroxide anion, which looks like that. Now, here's the important thing. The negative charge over there is more stabilized than hydroxide, hence it being easier to deprotonate. The reason it's more stabilized is the second oxygen over here is it's electronegative, so it's pulling electron density towards itself, so it stabilizes that negative charge. But we also get something which is known as the alpha effect, which is when the two heteroatoms which are next door to each other are able to interact with each other and within molecular orbitals. The lone pairs of electrons, or the orbitals that have the lone pairs of electrons in, are able to overlap. The net effect of it is that it raises the highest occupied molecular orbital, raises the energy of the highest occupied molecular orbital. It means ultimately what this is that this negative charge that we have here is much more softer. And so as a nucleophile, this is actually a soft nucleophile, whereas this hydroxide is a very hard nucleophile. And so the reaction occurs by adding to in the standard conjugate addition, and that's why we're talking about this here. And so our intermediate is going to look something like this. And what happens next is the enolate comes back, and the pi electrons are able to add to this oxygen over here, kicking out hydroxide as a leaving group, which is absolutely fine because the hydroxide, although generally is not a good leaving group, we do have hydroxide in solution, and we're able to use that to go and do some further deprotonations, and that gives us the product over there. All right, so this is just an alternative to epoxidation. It only works with electrophilic alkenes. This is a nucleophilic alkene, all right? But electrophilic alkenes, we can use a nucleophilic epoxidation method, which is hydrogen peroxide with some base present.